Hello, welcome to the part 1 of the week 10. So today and this week we are going to talk about the genetic algorithm. So our objectives are these. This week we are going to study the genetic algorithm and the traveling salesman problem, okay? The objectives are, of course, the understanding when and why the genetic algorithm can be used and can be applied, and you have to memorize the structure of the genetic algorithm, right? So previously we have talked about the selection sort and the merge sort, right? And the dynamic programming and recursion, and these all have some unique structures. For example, in recursion, we have we define a function here, and we have the same function within inside of this function, right? So this was a typical structure of the recursion. And the other thing is that dynamic programming, which has some kind of for loop function, and there should be some loop here, and there should be a memoization table up front. And that was the structure of the dynamic programming. And of course, genetic algorithm has these unique structures. And in terms of the unique structure, there are some strategies that you have to implement in the genetic algorithms. And one of them is the encoding strategies. And also there are other steps, otherwise encoding strategies, which are selection step and crossover step and mutation step and substitution step. And these are all important steps to make this genetic algorithm work. Okay, so we are going to cover this the topics in this week. So first of all, most of you may not be familiar with this genetic algorithm idea, so we are going to introduce that to you. So a difficult problem. Let's define a difficult problem. What makes a problem difficult? This genetic algorithm has been utilized to solve one of the most difficult problems that we have uncovered so far. Right. So before we introduce the solution or the handling method of these difficult problems to you, first we might have to talk about what is the nature of this difficult problem first. And what makes a problem difficult is first the easy problem is like there are unique solutions. If there are unique solutions and there is a pretty simple solution to that problem solving approach to that to that solution, then we can call that problem easy problem. So for example, finding maximum here, it is pretty easy because that we know the binary search tree is structured to have a left-hand side lesser values and the right-hand side bigger values. And finding maximum is actually basically just following the right-hand side, right? So that's very typical solutions, and there is a very clear instructions of how to get this solution with a given problem. So that is being called easy problem. For example, the further difficult problem is like this. For example, let's imagine that we are traveling. We have to visit these 6 cities. So let's imagine this is Seoul, and this is Daejeon, right? And this is Gwangju, and this is Busan, and this is Daegu, and this is Gangneung, right? I'm not sure about all the spellings correct, but anyway, it's Korean series name. So, okay, so let's imagine that we have to visit all these cities. Visit all these six cities. Let's imagine that. And we want to minimize the traveling cost. How about this? In that case, it will be a pretty bad idea moving from Seoul to Busan, Busan to, let's imagine Gangneung, and Gangneung to Gwangju, and Gwangju to Daegu, and Daegu to Daejeon. That would be a really hectic idea, very foolish idea to travel these six cities, because that basically what I did is just traveling from one end to another end of this country. Rather doing that, why don't we start traveling from Gwangju to Daejeon to Seoul to Gangneung to Daegu and Busan, like this. So in that case, it's kind of circling this country, and I believe that is one of the most easiest way and the most efficient way to travel these six cities. And why this makes so difficult? Because that this problem has how many solutions? Actually, is really true solution is just one route of travel, but there are how many possible answers? Actually, there are this many possible answers, right? So difficulty, what makes a problem difficult is the difficulty in implementing algorithm. If you are good at programming, difficult algorithm implementations can be easy, right? It just depends on your skill. It doesn't depend on the problem natures, right? And difficulty in understanding an algorithm, if you are smart, you might be better understand that algorithm. So that depends on your skill, not the problem nature. Difficulty in calculating a solution in a given time or your lifetime. Actually, that depends on the problem's nature. For example, we have only 1, 2, 3, 4, 5, 6. 6 possible candidates of the possible solutions, right? So it means that the finding maximum problem can be solved with a naive approach. Naive means, I'm just gonna speak in Korean, 순진한. It can be solved by a very naive approach with order of n. However, traveling these 6 cities has n factorial times of the possible routes. Means that if we just take the naive approach, it's going to take order of n factorial, right? And if n becomes large, this is going to grow very fast. It's going to grow faster than the exponential case. So in terms of the bigger notation, this is the linear, right? Linear. And the n squared, right? N cubed, and exponential, and it's going to be bigger than exponential, n factorial, right? And this is n squared, right? This. So means that n factorial and is one of the most difficult problem in terms of its problem nature. So this really depends on your skill. And if you are smart and if you are more skilled, then these difficulties will go away. However, this is the problem coming from the problem itself, and there is nothing that we can do about it. So these problems, the difficulties coming in from these categories is the most difficult. So, okay, I'm just gonna erase it for a second. So, as we can see that finding a maximum value of this structure is going to be order of n or order of log n if we just take the tree-based approach. So, means that we can take the smarter way to compare this, right? So we can solve the problem in a more efficient fashion. However, finding a travel time, travel plan, minimizing the trip time is going to take order of n factorial, and there is given a look, there is nothing that we can do about it. So it's going to be order of n factorial, and it's going to be a very difficult problem. So imagine that algorithm that can solve this problem given a size of x. Then if we increase the size just one little bit, and it's going to take a x plus 1 more time to solve it, and it's going to be keep increasing. So this genetic algorithm is designed to solve these types of difficult problem, right? So easy problem, there are a bunch of solutions that we can apply, but these difficult problems, we do have a solutions to it, okay? And that is being called the genetic algorithm. But because it's a difficult problem, there is a certain limitation to that solution.